binomial theorem world today, but we're just diving a little bit deeper. Okay? So ultimately, though, guys, our main objective is really knowing the binomial theorem. This is the main objective for today. We gotta know that binomial theorem. When we know it, applying it and identifying coefficients, all of that will come into play by just knowing the binomial theorem, okay? So all math textbooks will always have a formal mathematical definition and formula, okay? So here's that binomial theorem. You saw it yesterday. When we were expanding a binomial, we know it expands to so many terms. It depends on what the n is. So the number of terms is always one more than what the n is, that exponent, right? So this is just n in general, okay? I know it looks scary, but that's why we didn't start with this yesterday. I don't want to scare you off, okay? But all math textbooks are going to be like this, especially when you guys get into college. They always throw the weird stuff looking, at you first. And then you're like, oh, okay, after you actually try it, you're like, oh, that wasn't that bad. It just looked really bad, okay? So we're back to that sigma notation from the arithmetic and geometric series. We use sigma to represent a sum. We had a bunch of terms that we were adding together. We couldn't really add them together. They weren't like terms, but they're still being added together. We connected them with a plus sign, right? So it's still adding. Adding is a sum. So to write that in a quicker way, they use the sigma notation. So here is an example. So this is not an actual formula yet, but it says, for example, in sigma notation, a plus b to the third power. This expansion can be written as the sum of k equals 0 to 3, so the first three terms, which makes sense because it's up to 3, power of 3, of 3 choose k, so there's our NCR, of a to the 3 minus k, b to the k. These things are next to each other, so they don't put the dot there, but it really is there because next to means times. Okay, so that's an example of it. Now we're going to use that example to actually write the binomial theorem. So now we're going to write it using that summation notation, okay? And sigma to do it. So a plus b to some power n is going to equal the sigma, the sum of k equals 0. You always start at 0 all the way up to whatever that n is, that exponent, of n choose k. And then instead of an a to the 3 minus k, it's an a to the n minus k times b to the k power. So this is our formal definition for the sum of the expansion of a binomial. Okay? I know it looks weird. Hang on. When I show you how to use it, it won't be bad. So hang on. Don't freak out. No freaking out allowed. Okay? The reason why we have this notation is sometimes I don't want you to expand something all the way. Sometimes I just want to know one term. Like I want to know the 12th term in an expansion. I don't want all 15 terms of the expansion, I just want the 12th, okay? So when that is the case, there is a smaller formula that we can use. It says to find the rth term. That's in whatever term we're looking for. In any binomial expansion, we can use this. So this is what we're gonna be focusing on today, this formula, all right? So there's lots of letters up there, right? I see N, I see R, I see A, I see B. There's a lot of letters there, but it's okay. You should be able to tell what to plug in for each of those letters, all right? So in number 2, it says evaluate the expression n choose r minus 1 of a to the n minus r minus 1 power, b to the r minus 1 power for n equals 10, r equals 4, a equals x, and b equals 3. So look at what they gave us. They gave us what to plug in. Plug in all of these things. We've got n is 10, r is 4, a equals x, and b equals 3. Plug them in, plug them in. minus 1 down there. We'll clean that up in the next step, okay? Then we need a. What am I plugging in for a?
X.
X. So I need x raised to the n. What's n?
10.
10 minus, in parentheses, what's r minus 1?
4 minus
4 minus 1. It is going to be 3, but I'm not cleaning anything up yet, so just hang on, okay? And then next to means times. I'm going to go ahead and put times because I think that helps when we remind ourselves that. What are we plugging in for b? 3 to the r minus 1 power. What's r?
4.
So 4 minus 1 power. So here's what it looks like when we plug in all the things. Okay? Now let's clean up all the things. For instance, what's 4 minus 1?
3.
So 10 choose 3. Of x raised to the, well, 4 minus 1 is 3. What's 10 minus 3?
7.
So x to the 7th power. Times 3 to the, what's 4 minus 1? 3rd power. Power 3, right. So now we just have to clean up that 10 choose 3 and the 3 to the 3rd, okay? So 10 choose 3. You can use your calculator, or you're expected to use your calculator. 10 choose, whoops, not factorial. 10 PRB and CR3, it is 120, you're right. Okay. So I'm using a different color. That's 120 times x to the 7th times, what's 3 to the 3rd power?
So 27.
27. So now all we have to do is multiply these two numbers together, because remember, next to means multiplication. I'm just putting the dot in there to remind us that. And we just have to multiply 120 times 27, because this is the coefficient that's going to go in front of that x to the 7th. So 3,240 x to the 7th. And there is this expression evaluated, right? We're just simplifying it using what we learned yesterday, but we just found one term in the sequence, or not the sequence, in the binomial expansion. So if you guys remember, if we did the homework from last night, number 24, you had to expand this whole thing. It has, 7 terms, this is the 6th power, so there's 7 terms. So this is the whole expansion. What this formula does, it's saying, let's find the 4th term. And then you're just finding that term only. That's what this is doing, okay? So it helps us just find a single term in the expansion and not necessarily the whole thing. Yeah, sometimes you will need to find the whole expansion, but sometimes they just want one term. And that's all you gotta find, okay? Using that formula. So this one would be, if it's, what was the problem? So it was x and then x plus 3 to the 10th. So yeah, this would be the 7th term. Yeah. Oh, no, it's not. R is 4th. So this is the 4th term actually. Because it goes 10, 9, 8, 7, right? Because it starts at the high and then it goes down, so it's the 4th term. Okay. All right, turn the page. All right. Number 3, it says find the coefficient of the 6th term in the expansion of x plus 2 to the 11th power. So I'm going to rewrite that formula because we're going to need it. So n choose r minus 1. Yeah, guys, when you pull out your workbook pages, make sure you pull out all the pages for the lesson. It's never just one page. It's rarely just one page. A to the n minus r minus 1 times b to the r minus 1. So this is our formula that we just used. And now we're going to use it. Now they're going to tell us what term we're finding. So it says we're finding the 6th term. Well, that means that